Morning, dear students. Yesterday, or in previous class, we discussed about circles and some problems on circles. And today, we will discuss about parabola. So our topic is parabola. So let us start. So my name is Ramchander, contract lecturer in mathematics, working at SRRS GPT Sirsilla, branch general section, subject engineering mathematics, code 202, first year second sem. So our topic is elements of conic sections. In that subtopic is parabola. So today's class objectives. On completion of this class, you would be able to learn introduction and definition conic section, derivation of conic equation, introduction to parabola and its definition. So see the diagram. This is what is this? This is a cone. So conic section. A conic section is a plane section of a cone. The popular cross sections of a cone are parabola, ellipse, hyperbola. So these three are mainly we say conic sections: parabola, ellipse, hyperbola. Of course, circle is also a conic section, but mainly we say these three. Try to imagine a plane cutting a cone at different angles. So in previous class we discussed about circle. Let's see the cone, and if it is cutted by horizontally, so then that section part is looking like a circle. Next, if we cut some different angle, then the shape is not like a circle. It is a little bit different with circle. So that is called ellipse. And if we cut some more angle, like in the figure shown, after cutting, it is called a parabola. And if we vertically intersected the cone, then that parts are called hyperbola. So in different angles, if we cut the cone, the shapes are different, and that shapes are named like circle, parabola, ellipse, hyperbola. So when the plane touches the vertex, it produces a point. When the plane touches the vertex, it produces a point, a line. two intersecting lines. See, in figure 1 a point, figure 2 a line, figure 3 two intersecting lines. So conic section, if S is a fixed point, Mn is a fixed line which is given here in the dotted red color. P is a point moving such that SP by PM equals to constant. So SP by PM equals to constant. Then the curve described by P is a conic. See, each point is based on a condition, that is SP by PM equals to constant, or we can say SP equals to PM. So the fixed point S is called a focus, and the path is called a conic section, and the fixed line is called Directrix. It is Mn line is called a Directrix. Axis of the conic, a straight line which passes through the focus and perpendicular to the directrix is called the axis of the conic. So vertex. Axis of the conic means in previous diagram we can say x-axis or which is perpendicular to directrix and passing through the focus. So here x-axis is not, which is passing through the focus, and directrix means it is parallel to x-axis here in this diagram. Vertex, a point at which the axis meets the conic is called vertex. The constant ratio. So here axis and vertex we can see in another diagram, because here the path conic is explained, but axis is not displaying. And the constant ratio SP by PM is eccentricity and is denoted by E. So eccentricity equals to SP by PM. So that equals to, we can denote it by small e. The ratio SP by PM, SP and PM. We say eccentricity. And look here, S is a fixed point and P is a point such that SP by PM. So here the distance are same in parabola, or SP by PM equals to, we get some fixed value. If E equals to 1, I already told you, SP equals to PM, then it is conic is called a parabola. So see here, SP equals to PM, then SP by PM equals to 1, then we say eccentricity is 1, and that is conic is called parabola. See here, we can see the diagram, and that conic is called parabola, and here focus is given in a black dot, and from that focus which is passing through and perpendicular to the directrix, we can call that is as a axis. And after the black, on the line which is perpendicular to MN, and where the red dot is appearing, that is called vertex. So if E is less than 1, for example SP by PM is less than 1, then the conic is an ellipse. The conic is called an ellipse, like an oval shape. Next, if E means eccentricity is greater than 1, the conic is a hyperbola. See the diagram. So ellipse is a closed curve, hyperbola is a opened curve. In hyperbola we have two focus, two directrix. In ellipse also same, two focus, two directrix, two vertex, mainly two vertex in ellipse, or we can take four vertex also, and one center point in both ellipse and hyperbola. Next, theorem. The equation of a conic is of second degree in x and y. So the equation of conic is we will get second degree. See here, blue color line is indicating a conic, and S is a fixed point, and that blue color we can say it is a parabola. S is a fixed point given x1 comma y1, and if the dotted line is called axis of the parabola, and it is passing through the focus and perpendicular to directrix. So where it is cuts, that point O is called vertex. So here O is a vertex, MN is a directrix, and P is a point on the parabola, and it is mouse, or it is fixed like SP by PM. However, in the diagram the distance is to look it is different, but actually the difference is same, that is SP equals to PM. So proof. Let the focus be as x1 comma y1, and the directrix MN be the line. So let the directrix of the line is ax plus by plus c equals to 0. Next, let E be eccentricity, and P x comma y be any point on it. Then SP, S is a point, P is a point. So distance between 2 points, that is SP equals to under root of x2 minus x1 whole square plus y2 minus y1 whole square. Here x2 y2 means P x comma y, and x1 y1 is as it is focus. So we can write under root of x minus x1 whole square plus y minus y1 whole square. Next, here the blinking line is, we can say, PM. So from point P to the fixed line directrix, so the PM is perpendicular distance, we can say, from point P to line MN. So perpendicular distance of P from AX plus BY plus C equals to 0 is PM equals to AX plus BY plus C by under root of A square plus B square. So the distance is we wrote. Now the blinking, we can say, is SP by PM is E, that is eccentricity. So SP equals to E into PM. That implies SP square equals to E square into PM square. So we substituted and squaring on both sides. Then after simplification we can write like this: A square plus B square into X minus X1 whole square plus Y minus Y1 whole square equals to E square into AX plus BY plus C whole square. Next, by simplifying, we get an equation of the second degree. Therefore, an equation of the form ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0 represents a conic section. So this is the conic section representation generally, that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. Some real life applications of conic sections. The planets revolve around the sun in elliptical orbits. You can see on solar system. Parabolic microphones perform a similar function with sound waves. Some real life applications of conic sections. Parabolic mirrors are used to converge light beams. Solar ovens. The trajectory of objects thrown or shot near the Earth's surface follow a parabolic path. Suppose we throw a ball, it reaches on the earth, so that moving path or the way is in the shape of parabolic. A parabola is used in the design of car headlights and in spotlights. So in that headlight, the mirror, we can say, in the form of parabola. Hyperbolas are used in a navigation system known as LORAN, long range navigation. Hyperbolic as well as parabolic mirrors and lenses are used in systems of telescopes. So now we will see the definition of parabola. Definition: parabola is the locus of a point which moves such that its distance from the focus is equal to the distance from the directrix. Parabola is the locus. Locus means nothing but path, the way, based on a condition. Here the condition is point moves on that path such that its distance from the focus means a fixed point, equal to the distance from the directrix. Directrix means a fixed line. Already we saw in the figure, in the previous figure, and you can see here also. So F is a focus fixed point, and passing through the focus one line is going and it cuts the parabola. We can say it is a vertex. Here vertex is a 0, 0, and that means parabola axis is a x-axis, and the dotted line vertically, that is a y-axis, and a fixed line directrix at a distance of a. So focus also with the distance of a from vertex. So left side we can take it is a negative, and right side from origin you can say it is a positive distance. So we can fix focus point as a comma 0. Standard equation of a parabola: y square equals to 4ax, where a is greater than 0. Take O as origin, OS as x-axis, and OY as y-axis. Let S be the focus and Mn be the directrix of the parabola. See, S is a fixed point, focus, and Mn is a directrix. Draw SZ perpendicular to the directrix Mn. You can see in red ink. Let O be the middle point of SZ, because O is a point and it is a middle point from SZ, because fixed point is suppose it is located from O, particular distance is say A, and the same distance will be there from O to Z also, because that is a fixed line. Z point is on the Mn line. So O is a center point and O is called vertex here. Next, let P, x, y be any point on the curve. Join PS and draw PM perpendicular to directrix, and PL is perpendicular to x-axis. From P2 we draw a line which is perpendicular to x-axis, that is called PL. Take OS equals to OZ equals to A. Then the coordinates of S are A comma 0 and that of Z are minus A comma 0. Next, the perpendicular distance from P to MN equals to PM equals to LZ equals to LO plus OZ, that equals to X plus A, because LO is, we can say, X and OZ is A, so LZ equals to X plus A. By definition, SP by PM equals to 1, then SP equals to PM, then SP square equals to PM square. So SP means the distance between 2 points, so A comma 0 and X comma Y. So X minus A whole square plus Y minus 0 whole square equals to PM. PM is nothing but LZ, that is X plus A. Squaring on both sides means here left side root cancel, right side we put square. Then if we expand left side and right side, we get x square plus a square minus 2ax plus y square equals to x square plus a square plus 2ax. That implies y square equals to 4ax. This is the standard equation of parabola. This parabola is symmetrical about x-axis. So the blinking line is called parabola, which is in blue color. And the standard equation is, we can say, y square equals to 4ax. And this parabola is symmetrical about x-axis. Symmetrical means, you observe the diagram, we can see that x-axis is divided the parabola into 2 equal parts and equal shape. So it is like a mirror. So that's why we say parabola is symmetrical about x-axis. Axis of parabola, the line about which the parabola is symmetrical. See here, x-axis is dividing 2 equal parts, equal shapes, equal size. So the x-axis is here behaving like a symmetrical. That's why it is called axis of parabola. Vertex. See here, arrow mark is showing at O, the point where the axis cuts the curve. Here x-axis is cut the curve at point O, and that O is called vertex. Tangent at vertex, the blinked line. The tangent at the vertex and perpendicular to the x-axis. So here y-axis is a tangent vertex. Latus rectum. The focal chord LL dash. You can see a red marked line which is passing through the point focus and perpendicular to the x-axis or its axis. Then that LL dash focal chord, we can say latus rectum. Equation to latus rectum is x equals to a. As LL dash is parallel to y-axis and at a distance a to its right. because lattice rectum is moving or going or passing through the point focus. So focus is at a comma 0. So then equation of lattice rectum is x equals to a. The coordinates of L and L dash are a comma 2a and a comma minus 2a. So L dash are where the lattice rectum intersects on the parabola. The length of lattice rectum equals to 4a because upper part length is 2a and lower part length is 2a from axis. So 2a plus 2a, 4a. Equation to directrix is, so directrix is a fixed point and it is equal distance from which is focus is from O origin, and in the same way in the opposite direction from origin to which is the distance of the focus, same distance here also applies, and having that same distance the directrix line is there. So the focus is located at x equals to a, and in the same way in the opposite direction on the same distance, that is a. So to the right side we say positive, in left side we say negative. So minus a, in the minus a on the x-axis the fixed line will be there. So its equation is, we can write x equals to minus a, and from directrix to origin and origin to focus, so these distances are same and equal. Then we say O is the middle point, or vertex is the middle point in this diagram. So in different diagrams there need not be origin, there is any point, but the condition is from vertex to focus and the vertex to directrix, the perpendicular distances are equal, because vertex is act like a point P. So SP equals to PM. This is the condition. That's why vertex is the middle point of focus and directrix. So these two are, that is 2 means focus and directrix. These two are equidistant from origin. That is, we have to remember. So equation to directrix is x equals to minus a. Next, parabola is here given and focus S. Thus for the parabola y square equals to 4ax. Here dot black bold shaped line we say x-axis, that is ox. X-axis is the axis and its equation is y equals to 0. Origin O is the vertex because here the axis cuts the parabola at O. So we can say that point is called vertex. The y-axis is the tangent at the vertex. So it touches the vertex here OY, that is y axis is called tangent vertex, and y axis equation is, we can say, x equals to 0. So tangent line or tangent vertex equation is x equals to 0. Equation 2, latus rectum is x equals to a, because latus rectum is passing through the point focus. Yes. Equation 2, directrix is x equals to minus a, because focus is at the distance of a, then directrix is also same distance, but the direction is different. So it is left side of the vertex, so its equation is x equals to minus a. So here mn line is called fixed line or directrix, and its equation is x equals to minus a. Next, summary. Today we have learned the following: introduction to conics. So conics means which are coming from a cone by cutting different angles, and mainly here we are discussing three, that is parabola, ellipse, hyperbola. And these of course circle and line also we can see in the conic in the cone, but mainly we already saw the circle. If we cut the cone horizontally, then after cutting, that place is in the form of a parabola, that shape is. So here already we discussed circle, so remaining three parts mainly, that is parabola, ellipse, hyperbola. So these are mainly, we say here, conic sections. And equation of a conic, general equation we showed here, that is x square plus y square plus 2hxy plus 2gx plus 2fy plus c equals to 0. Three conics are different conditions, that is sp by pm equals to e, we say, that is eccentricity. So at parabola e equal to 1 and e is less than 1, we say ellipse, and e is greater than 1, we say hyperbola. So based on eccentricity, we can decide that conic section is it parabola or ellipse or hyperbola. If sp by pm is 1 or sp equals to pm, then it is called parabola. And parabola contains one fixed point and one directrix, that is a fixed line, and its axis, and the vertex is the middle point of focus, and directrix line where it cuts the axis to directrix. And on the parabola, if you take any point P, it is follow the condition. The condition is SP by PM equals to 1 or SP equals to PM. So equation of a parabola, we are showed here. The standard equation is y square equals to 4ax. There are so many equations, but one we are primarily we took and we showed the equation of parabola. It is y square equals to 4ax. We can say that is in first form. There are so many forms. Here we learn 8 forms. We will learn in further classes. So focus, directrix, axis of parabola. Focus means fixed point is called focus. We can indicate it as a S or F. Directrix is a fixed line where the focus is located from vertex in the same way, in the same distance, in another side to the vertex. The directrix or fixed line is located. That fixed line is called directrix, and a fixed point is called focus, and which is passing through the focus and perpendicular to the directrix, passing through the focus and vertex and perpendicular to directrix, that line, and which is symmetric to the parabola, and which line is shows like symmetrical. So that is called axis of parabola. Quiz. Name any two conics. So we can say easily parabola or circle or ellipse or hyperbola. What is the eccentricity of a parabola? Here 3 options are given: A1, B2, C 0.5. So we discussed here parabola means SP equals to PM or SP by PM equals to 1. So SP by PM is nothing but we say it is a eccentricity. So E equals to 1. So eccentricity of a parabola is 1. So answer is A. What is focus of y square equals to 4ax? So y square equals to 4ax is a standard equation of the parabola, and focus means fixed point, and it is particular distance from origin, and that is A. From origin to or vertex to focus, the distance is A, and in y square equal to 4ax, the focus is located or exists on the axis, and the axis is x-axis. On x-axis, y value is 0, and the distance on x-axis is up to focus from origin is A. So focus point is A comma 0. So your options are given: A is 0 comma 0, B is A comma 2, and C is A comma 0. So answer is C. Next, what is the vertex of y square equals to 4ax? Again, it is given a standard equation of the parabola y square equals to 4ax. We already discussed here what is standard equation and what is its focus, axis, vertex and directrix. So here asking what is vertex. So in y square equal to 4ax, x-axis is its axis, and where the x-axis or its axis cuts the parabola, at that point is called vertex. So here x-axis cuts the parabola at point O. So O means origin, where x and y axis are intersected. That point is called O. And here we say the axis of the parabola cuts the parabola. Where it cuts the parabola, that point is called vertex. So here axis of the parabola is nothing but x-axis, and x-axis cuts the standard parabola of y square equal to 4x at origin O. So origin means 0, 0. So three options are given. Let us see what are the three options. A is 0, 0. B is 0, 2. C is 2, 0. So the vertex is origin, so 0, 0. So answer is A, that is 0, 0. And here three questions are given. So remaining you have to do from exercise. So in the textbook, in each and every chapter, we have exercise problems. So on this topic, on parabola also, we have so many problems. So open your textbook and see the diagrams. In textbook there are so many forms given. Here we discussed today only first form, that is y square equals to 4x. And in further next classes we discuss remaining forms and different forms and different problems based on different data. So today we learned first form, and you can easily understand second, third, fourth, because only its direction is changed. Remaining points and remaining conditions are same. Just direction change means positive to negative or negative to positives. That values will be changes. So mainly 8 forms. First 4 forms containing vertex is 0, 0. Remaining 4 forms vertex contains h, k. So if you understand the first form, you can easily understand remaining 7 forms, because the condition is same. Condition means SP by PM equals to 1, or eccentricity is 1. So this is the condition. Wherever the diagram locates on the x-axis or on the y-axis or on first quadrant or second quadrant or third quadrant or fourth quadrant, and if it is vertex is other than origin, whatever it may be. If it is parabola, means condition is SP by PM equals to 1 or SP equals to PM. So if you understand this, you can easily know the remaining forms, and we can do the problems on the parabola. And if we know how to do the parabola problems, then we can easily do the ellipse and hyperbola problems, because same style, same procedure, just eccentricity will only change. Remaining process and concept, everything is same, because these are 3 conic sections on different intersected to cone. 3 or 4 are different diagrams formed. So based on eccentricity, we are classified here parabola, ellipse and hyperbola. So if you think the concept of the eccentricity, then you can easily understand how the equations are formed, how the diagrams are formed, and what are the conditions, what are the points here we are mentioning, that is focus or vertex or tangent vertex or directrix. So all these we can find from the equation, and by using these points we can form the equation. So in the both way we can do, and on this condition there are so many problems given in exercise also. So you, before going to exercise, first see the presentation, and after that you see the example problems, and then try to do the exercise problems. And if you have any doubts and you are facing any difficulties in solving questions, then you can ask me or post me your doubts on WhatsApp, and I will explain your doubts or clarify your doubts. So do the problems, and we'll discuss remaining in next class. Thank you.